Hello, everyone. Thank you for joining today's presentation entitled Security versus Development, the SDLC's Game of Thrones. My name is Marie Peters, and I'll be moderating today's session. It is now my pleasure to introduce today's presenters. Representing the Security House is Nabil Hannon. Nabil is a managing principal at Cigital and is a 10-year application security veteran with extensive experience performing penetration tests, code review, threat modeling, and architecture risk analysis. Representing the Development House is Ian Spiro. Ian is Codiscope's Director of Security Strategy and Research. Prior to joining Codiscope, Ian spent the better part of 8 years at Alps Labs and IBM developing solutions for security teams.
Thanks, Marie. Can you hear me okay?
Sure can.
Okay, fantastic. So, hi everyone. Thank you so much for joining and listening to us today. My name is Nabil Hannon. I work as the managing principal for Cigital, and I oversee all of Cigital's business and operations in the Northeast USA as well as Eastern Canada. So today, I'm going to be playing the role of the security professional, and ultimately, as someone in the security space, my goal is to help businesses and organizations identify potential security issues that are in their software and help them to make their businesses more secure and understand what type of risk exposure they have. I truly believe that this can happen effectively by building security into the software from the get-go instead of using security as an afterthought. And from weapons perspective, there are multiple techniques we can use to identify security risk, things like static analysis, code review, dynamic analysis and pen testing, training, architecture analysis, and so on. So that's what I'll be talking about today.
Hi all, my name is Ian Spiro. I'm the Director of Security Strategy and Research at Codiscope. I've been working in static analysis tooling space for the majority of 10 years, and right now I'm working on building a next generation static analysis tool. I'm representing development in my role today, and as a development lead, I'm very wary of security picking the tools that they believe are correct for my development environment, and especially the reactive security point of view, where after I think everybody is done with their functional requirements, I get a list of bugs that now are the highest priority and need to be fixed immediately. My development teams have their IDEs, their unit testing frameworks, and all of our automated tests already picked out, and everything works fine until security comes and gives us new requirements late in the life cycle. I'm hoping that we can have a clean battle today.
So thanks. On the topic of battle, we know that there are many things that tend to lead up to war. So we'd like to hear from both of you about the things that you see that tend to cause conflict between the two sides. So the first thing up it looks like we have is security responsibility.
Sure. Yeah. So, I mean, if we look at security, ultimately it's the security teams that are there to do a lot of the heavy lifting around activities that identify security issues and try to build software securely. And ultimately what has to happen is there needs to be some type of a top-down corporate or company-wide effort to make this successful. And this obviously requires investment in people, committing resources and allocating resources to do the work. And of course, it needs to be done proactively instead of reactively. We tend to find a lot of organizations are always in a reactive mode when it comes to security, especially they tend to focus on it after some type of an incident has happened. But I think in the long run, companies need to start thinking about how to get to that proactive mode to think about software security as part of the whole software security, software development life cycle instead of it being an afterthought after the software has already been built. That being said, reactive security is better than nothing. So even though that's where we are now, we need to start thinking of how to get to a more proactive approach.
So I would completely agree that security is everyone's responsibility. It needs to be designed in from having the proper requirements at the beginning of the process to the testing frameworks that are necessary to find and fix these things that we all agree we want to keep out of our code. What I would counter with, though, is that if security is truly a business priority, then it's mandated that your security teams give us the appropriate tools to accomplish the job, and probably even more importantly, training to use these tools. Not just training around secure code practices, but specific training in how we should be using the tools that are supposed to help us automate this job. I agree reactive security isn't where we want to be. In fact, it's really a killer for the development processes that my team has in place. There's really nothing worse than getting a list of 1,000 bugs that haven't been vetted from the security champions and told that even though we've done what we believed was our job, getting the functional requirements up and running, now we have another set of high priority items that need to be fixed immediately before we can say we're finished with development.
So I think that kind of brings us to an interesting topic around the tool deployment and how to use tools effectively as part of an organization. Ultimately, there are tools out there that help with finding software security issues, but as we understand with different types of tools, they tend to be noisy, and of course you can't expect the dev organization to understand how to use the results and even how to use the tools effectively because they tend to be very complicated. So ignoring the security aspect of things and ignoring the requirements coming down for security is not the answer in this case either. Ultimately, you know, tools need to be deployed so that they can work with the development organization and the development efforts and create as minimal friction as possible. So, you know, and a great example would be something like Codescope Secure Assist, which is an IDE plugin that helps developers find and fix and ultimately prevent vulnerabilities from the get-go because it's identifying vulnerabilities as part of the regular development process without needing to go through any separate workflow, and also not inundating developers with thousands and thousands of issues. You know, I think it was Jim Routh, the CISO of Aetna, who in a recent webinar said that if you can integrate static analysis tools into the development lifecycle to work in tandem with the developer's regular workflow, that organizations can see 15 to 20% a year-over-year productivity gain because of that effort and the process and development leveraging the tools effectively. So what are your thoughts on that, Ian?
I would agree that proper choice of tooling is crucial to enabling proper conversation to happen between security and dev. My experience and my team's experience using static analysis tools is that they're really riddled with false positives. They take too much time for my team to investigate what may likely be a miscommunication or misunderstanding of the programming languages and the frameworks that I'm using. And after all is said and done, once you've hunted down a number of false positives, you really lose confidence in the use of the tool in general. It seems like, although I agree Codescope Secure Assist is very nice because it, you know, scans files as I'm opening things. Anytime I make what I think is a fix and save the file, it rescans to let me know that I have, you know, done things correctly or again incorrectly. But I find that the lack of framework understanding in static analysis tools is really a killer. I can't tell you how many times security has come to my team and said, you need to be doing input validation. We don't see you're using any framework level controls, but they simply don't understand how the interceptor stack works in Spring MVC, and what they're asking for is simply found in configuration files, not in the code itself. That's just indicative of the way that frameworks have really become a crucial tool for my development team, and something that it just seems like static analysis vendors in general haven't given credence, or maybe they just don't have the technologies to fully understand how these frameworks affect the data coming into my applications. So false positives are a real issue for my team, and I wish that security could, set up some kind of filtering mechanism so that nothing is ever brought to our attention as needing to be fixed immediately when in fact it doesn't need to be fixed. The fix is already there, or it's simply a misunderstanding of the tool or the security team running the tools. On the other side of the house, I really like the dynamic analysis results that your team comes with because they're proof positive. I can see that there's definitely an exploit for this vulnerability, but conversely, I don't know where to fix it, right? You give me a URL and you give me a payload, but that says nothing about where in the code I should be making this fix to, one, mitigate the existing vulnerability, but even more important for my team is to understand how to securely code in this language and this framework moving forward. That's what I'm really interested in getting, is a tool that, one, understands my choice of programming languages, my specific frameworks, and two, can actually teach me to become a better programmer. It seems like training is one of the missing bridges between our teams right now.
Yeah, that brings up a great point, actually. So, I mean, ultimately, you're correct. The static analysis tools that are available right now in the market, they do a pretty poor job of understanding framework usage. But also, conversely, the pen testing side of things, you get real exploits, but you don't know where to go track the issues down. Ultimately, the way to do this work is you really have to have security involved in the development process from even the whiteboarding sessions before any code has been written. Because ultimately what happens is, especially with tool deployments like static analysis, you can get very effective results if you can fine-tune and write some custom rules for the static analysis tools so that now the tool will actually understand what frameworks you're using, or it will have the ability to understand any custom developed code that you have that's taking care of a specific security control like input validation or output encoding. And once you can integrate and have security involved in the software development process from the requirements and the requirements phase when you're whiteboarding and designing your system, security can actually build those rules into the static analysis engine. So not only are you getting good quality results from the pen test with issues that are truly exploitable, but you're also getting the deeper internal look at the code level to understand where you need to go and address those issues, and you can have confidence that these issues are true positives. Additionally, you also need to have expertise and security experts to review the results of static analysis code review results to ensure that the false positives get vetted and removed, because that is a common problem, and you do need a certain level of expertise to be able to do that effectively and quickly, which, to be honest, most developers don't have because they're not necessarily thinking from the security perspective. They're more focused on implementing the functionality that are part of their requirements that they have to go and implement. So that definitely makes sense, and I think there are approaches that can be taken. As I said, this again involves resources and time that has to be put in, and security needs to become more of a proactive approach.
Just to counter, I absolutely agree in the notion of building security in from the beginning, and having your team involved in the user story creation and at the beginning of our sprints is crucial to ensuring that we're on track to building secure software. But I still find that just giving us a list of things to avoid doesn't equate to actual requirements. It's really hard to prove the absence of a vulnerability. And what I really need from your team is, for you guys, you understand security, you have programming expertise as well. I want you guys to do the hardcore security research to say, not only do you need to avoid cross-site scripting and SQL injection, but hey, we understand you're working on a new Node.js application. what we recommend is that you use, we've done the research, you should use the Happy framework for your routing, for your HTTP routing. We want you to use the bcrypt plugin for that framework whenever you're hashing passwords. And we really, promote the use of Angular on your client side, view technology, because this way, we can be pretty confident that everything is contextually output in proper encoding standards. So rather than a list of things to avoid, I would really like it if the security team could do the research and come to the table at the beginning of sprint saying, this is what we recommend you use, and this will ensure that we're both moving down the same path together.
Yeah, so that's a great point. I think that brings us to the next catalyst that we had, which is around communication. And, I tend to agree that all those challenges are very real, and most development organizations face those challenges right now because security comes back with a list of things not to do. I think it's important that at the requirements phase, building the right software security requirements can be challenging, and avoiding things like, avoid OWASP top 10 or avoid SANS top 25 is not sufficient. So ultimately, we need to think about writing requirements that make sense for the system that you're building, and that's where we need to have requirements that say things like, all input coming in from an external untrusted source needs to be validated using this framework A, and then all output needs to be output encoded based on the context using framework B feature 1, and so on. And that can only happen if the lines of communication are open between development and security. And I think we're reaching a point where people are understanding the importance of security, but they need to embrace that the security teams are here to help build better software and not to create more roadblocks for developers. So as part of that, I think what really organizations need to start focusing on, and I've seen this happen at other organizations, is building out a software security framework where they actually put together a list of approved frameworks that will help you build certain software security controls into your software. And that also helps when we go back to the static analysis phase, is now we can actually test defined misuse or non-existent use of those frameworks. And if they're not being used correctly, we can have the standards that are part of the framework that we can give to the development organization and say, look, we gave you these things to help you build the software and the system more securely. You need to be using them, and here are some areas where you might have missed it, because we can train the static analysis tools to look for usage of those specific things, which I think is important and will make lives easier for both the development teams and the security teams.
Yeah, I mean, that sounds fantastic. If you could actually, come with suggestions of appropriate choices of frameworks and language-specific libraries that your team has vetted and you suggest that we use, that would not only give us confidence that you actually know what we're developing, not just from a functional standpoint, but actually the details of the programming language being used, and would create a lot more goodwill and certainly confidence within my team that security is here to make our software better in general. This is just one part of quality, and if we actually had tools that, first of all, understood dynamic languages like JavaScript, like Python, Perl, Ruby, all the stuff that my team is using, and then could give us not just negative feedback where we've clearly been misusing the framework or left out security controls entirely, but some kind of positive reinforcement mechanism that, in addition to training, can show my team without just passing your test that, oh, we've actually been learning some new secure coding practices and put those practices in place. I would like some positive feedback mechanisms besides just the lack of a list of vulnerabilities at the end of development to show my team and also management that this is a worthy investment and that our time spent using these tools and taking these trainings actually makes us better overall developers.
Mm-hmm. Yeah, I definitely agree with you on that. I think a common mistake that people make are they hire people to come and break their software, and those people tend to be security professionals that are coming in, but they don't necessarily know how software is truly built, or even understand the programming languages, or have never really written code. We see out there a lot of security professionals who are great at using different tools and open source items to break into software, but they don't necessarily know how to go and fix it and how to speak to developers and help them understand and give them that positive reinforcement on things that they're doing well and things that could be improved on. So I think we see a lack of that both in the tool space, because tools aren't proactively helping you understand areas where you've done well, but even security professionals tend to be very good at breaking things, but don't necessarily speak the same language as software developers. That's something actually that I pride in my own teams here, is that, you know, we only have people who come from a development background, and they really know how software gets built and understand the challenges that developers have, so we don't create a lot of friction when we interact with developers. But ultimately, that also makes them better at breaking the software because they know how it was originally built, and also helps them speak the same language with the development teams to help them understand that we appreciate the challenges they have and their focus on building the right functionality, but we can also give them tools and frameworks and code snippets, et cetera, that help them do the remediation of the vulnerabilities that have been found and do them more effectively than they would have if left on their own means.
Yeah, I mean, that's one of my ongoing issues with dealing with security folk up in their ivory towers, is that we're not speaking the same language more often than not. Especially if you bring in a pen tester at the end to break my stuff, there's already a bit of animosity because you're trying to destroy the stuff I just created. But then just telling me, yeah, this is broken, go fix it, just makes my team want to, you know, break your security process by coding around your tools, right?
Or proactively fixing things as I'm finding things.
Right,
so that has happened.
And what would be ideal is that if I know that your team actually understands the programming language and the ins and outs of my day-to-day job, then I think I would actually find more of my team members leaning on your resources to provide solutions for problems that haven't come up yet. Not only being invited to the beginning of the sprints, but having an ongoing conversation as we build more and more complicated functionality to say, hey, it looks like we're venturing into this area. Do you have any suggestions for the best way to go about this? Or have you seen some of the hot new frameworks that tackle this stuff for me? And then, you know, one thing that we've mentioned several times but just doesn't seem to have permeated the business culture is that my team needs training. It can't just be as I'm using security tools and I find there's a vulnerability, I go to Stack Overflow and I Google it and I try and find the fix for it. Like, I would like, you know, time, resources, and dedication from the company side to say secure coding matters to us. That's why the first couple days of every month, everybody in my team is invited to go and take a secure coding course. Or the people that are interested in crypto, well, you know, every quarter there's at least one trip to a security conference focused on crypto where you can learn the cutting edge of new technologies out there. Because if this is really going to be an investigation or an adventure that we go on together to learn how to build the best possible software, then I need to know not only your team can be leaned on as a resource, but my management is behind this, not just saying they are, but putting the financial backing that I need for my team to become a better, you know, a group of better developers.
Yeah, no, that's a good point. And I think the reasoning you gave for why we need more training and so on, it's important. But there's also some additional things, you know, we kind of understand that there are common conflicts that we kind of brought up earlier that kind of creates a roadblock. And makes everyone do more reactive things versus proactive things as part of their development process. But, if we want to kind of figure out ways we can maintain the peace between the two groups, there are actually other activities separate from doing tool integration that we need to also be thinking about. These are things like threat modeling that can be done regardless of what the SDLC is and regardless of what you're building. You can do things like threat modeling where you can look at a system as a whole and understand what components are going to be there in the system, identify what the different threat actors are that you would care about for your particular system, whether it's an internal app, external app, mainframe app, mobile app. The threat actors tend to change. Then, of course, being able to identify what type of assets you have within your system that you care about protecting, and then looking at your system as a whole and understanding what type of security controls need to be placed where in order to protect your assets from specific threat actors. And it's a very simple exercise that can be done on the whiteboard as part of the software development life cycle before you even write any code, but it tends to add a lot of value, and keeping these type of things in mind definitely help reduce the friction and maintain more peace, because both the development groups and the security groups get a better appreciation for the challenges that each of them are facing, and they can work together to make their lives easier and ultimately build more secure software from the get-go. So that definitely makes sense. Anything you want to add on the training side as well?
Well, just thinking about things in terms of threat modeling, I think that would be a really valuable exercise to have periodically throughout our life cycle, at the beginning, but then revisiting as we're, coming to the close of development, getting functionally complete and going back and making sure that the security controls we put in place actually do mitigate the threats that we're anticipating would be intensely valuable. And the way I've seen it, everything so far with static analysis and security tooling in general is about a risk-based assessment. And that just never made any sense. You come up with this risk assessment methodology, assign every single asset a number somewhere, and as soon as the network has completely disappeared, and everything's bring your own device and there's no clear boundaries, it just seems like a bunch of wasted effort, really. So I like the idea of, putting in place the assets we're protecting and the threat actors that we're protecting those from, and coming up with a holistic design and choice of technologies to make sure that we accomplish those. Again, I would just harp on the fact that training seems to be missing right now from our processes. And as much as possible, I would like the training to be up to date on, the cutting edge technologies that my team wants to use, and not just last year's Java framework, but this year's Node and Express and Mongo framework. I would say that training only goes so far, but again, positive reinforcement of what you learned in training, if we could potentially have a tool that as we learn up-to-date coding practices, helps to reinforce those in a day-to-day ongoing basis, that would be ideal. Maybe we wouldn't have to just battle when we come together.
Yeah, that would be nice.
Can anybody help?
I was going to say, I think you guys are here to help and kind of talk a little bit about, the conflicts that your teams face with each other. I don't think either of you are going to say that there's ever been a perfect harmonious relationship between security and development, but I think by putting on each other's hats and understanding where each other are coming from, it makes it a little bit easier to get along.